Hello everyone. For our mechatronics system design project, we created an experiment in which we could test PID control using two DC motors with propellers and a mechanism that allows motion in only two dimensions. Our project objectives were 1. Interface an Arduino microcontroller and L298H bridge to a gyroscope controlled by two DC motors, and 2nd, to use PID control to maintain stable flight. The mechanism we designed supports a modular base that holds two propellers powered by brushed DC motors. The base also holds the gyroscope on top and centered. The pitch of the motor mount is allowed to change by a free hinge. The roll is allowed to change about a wooden dowel. The driver board rests on the front of the bracket along with the breadboard and power connections. The Arduino is mounted on the back of the bracket. Here is a close-up of the propellers and motor mount. Here we have mounted the ME190 with 3-axis gyroscope. The electrical circuit is shown in the schematic. To implement PID control, we used the Arduino PID library in conjunction with the wire and IMU libraries needed by the gyroscope. This software-based closed-loop controller allowed us to write a program utilizing the three gain parameters to calculate and adjust the system output. In short, our program defines an optimal orientation for the gyroscope to be in while calculating the offset and making each motor spin at a higher or slower rate to correct the error and maintain the predefined orientation of the gyroscope. The user could adjust the proportional, integral, and derivative gain constants once before running the program and opening the serial monitor, which displays the 3-axis values read by the gyroscope. It should be noted that the program must be initiated and the serial monitor opened before the power supply is turned on, otherwise the program will crash. Our code can be referenced in Appendix B of our final report. One final note, we found that with the MPU6050, the behavior of the motors would be very different at times. On some occasions, one or both motors would fail to power on. We attempted to analyze the circuit, but found nothing to explain the sudden and seemingly random voltage drops. Eventually, we switched out the MPU with the Polulu IMU used in lab, and we found that the problem had disappeared.